Greetings, alchemists. Today we dive into a new topic, but before that, a quick recap. In our previous session, we journeyed through the realms of normal form, standard deviation, and z-score. We demystified these concepts and learned how they are instrumental in our data analysis quests. These tools allow us to understand and interpret data, helping us mold raw information into valuable insights. But what happens when our data refuses to fit neatly into a normal distribution? That's where today's topic comes in, a theorem that comes to our rescue when data distribution shies away from the norm. A theorem that doesn't discriminate and works with all data sets, regardless of their shape or form. Today we delve into the world of Chebyshev's theorem. This theorem is a powerful tool that broadens our horizons and allows us to handle the unexpected in data analysis. Now let's unearth the mysteries of Chebyshev's theorem. Chebyshev's theorem, named after Pafnuty Chebyshev, a Russian mathematician, is a gem in the world of statistics. So, what is this mystical theorem all about? Well, Chebyshev's theorem is a statistical rule that provides us with a way to understand the dispersion of data, regardless of the shape of the distribution. Unlike other theories such as the empirical rule, which works only for normal distributions, Chebyshev's theorem holds true for all types of data distributions. Quite a game changer, isn't it? Now let's illustrate this theorem with a practical example. Imagine being a card payment gateway service provider. Your job involves analyzing merchant transactions, and you're dealing with a huge amount of data every day. You are interested in understanding the behavior of these transactions to identify patterns or anomalies. Chebyshev's theorem can come to your rescue here. The theorem states that no matter what your data's distribution is, at least a certain percentage of data will always fall within a specific number of standard deviations from the mean. Specifically, for any given data set, no less than 1 minus 1 divided by the square of k times 100% of the data is within k standard deviations of the mean, where k is any real number greater than 1. So if you were to take 2 standard deviations from the mean, you could be sure that at least 75% of your merchant transactions fall within this range. You could use this information to identify transactions that deviate significantly from the norm, potentially flagging these as anomalies. Chebyshev's theorem provides a powerful tool for understanding and interpreting data, even when the data distribution is unknown or irregular. It allows data analysts to make meaningful inferences and draw powerful conclusions from data, thereby turning raw numbers into valuable insights. That's a lot to take in, isn't it? Let's break it down further. Imagine having a bag full of different sized gems. Chebyshev's theorem helps us understand how these gems are distributed. Picture this. Each gem in the bag represents a data point. Some gems are big, some are small, some are medium-sized. Now, Chebyshev's theorem is like a tool that tells us no matter the shape or size of these gems, at least a certain percentage of them will always fall within a specific range. Let's break it down. Chebyshev's theorem states that for any data set, regardless of its distribution, at least 1 minus 1 divided by the square of k standard deviations away from the mean will contain some portion of the data. In simpler terms, the greater the number of standard deviations we move away from the mean, the more data we include. To put this into perspective, let's consider an example from the card payment domain. Imagine you're a card payment gateway service provider analyzing merchant transactions. The transaction amounts are like our gems, varying in size. The mean transaction amount is the average size of our gems. The standard deviation measures how much these transaction amounts typically deviate from the average. Now, say you want to find out what percentage of transactions fall within 2 standard deviations from the mean. Chebyshev's theorem tells us that at least 3/4 of all transactions will fall within this range. Now, suppose you want to expand your range to 3 standard deviations from the mean. Chebyshev's theorem again comes to our rescue, ensuring that at least 8/9 of all transactions fall within this range. So, you see, Chebyshev's theorem gives us a safety net. It provides a minimum proportion of data that will always fall within a certain number of standard deviations from the mean, no matter how our data is distributed. Now, isn't that interesting? But why should we care? We'll explore the importance of Chebyshev's theorem and why it's a golden tool for data analysts in our next scene. So stay tuned and keep converting data into gold. And as always, don't forget to like, subscribe, and share this video. Chebyshev's theorem is our torchlight in the dark alley of non-normal data distribution. Now you might be wondering, why is this theorem so important? Well, let me tell you, in the world of data analysis, we don't always have the luxury of dealing with a perfect bell curve or a normal distribution. Sometimes the data we're working with is skewed, clumped, or just plain unruly. That's where Chebyshev's theorem comes in. It provides us with a safety net, a way to make sense of data even when it doesn't follow the rules. But let's not just talk about it, let's see it in action. Imagine you're a card payment gateway service provider. Every day you're processing thousands, if not millions, of merchant transactions. Each of these transactions is a data point, and they're not always neatly distributed. Some days you might have a rush of transactions, other days it might be slow. The data is unpredictable, non-normal. So how do you make sense of it all? How do you find patterns and make predictions? Enter Chebyshev's theorem. With this theorem, you can calculate the proportion of data that falls within a certain number of standard deviations from the mean, regardless of the shape of the distribution. This means even with your unpredictable transaction data, you can still make meaningful analysis and predictions. But the importance of Chebyshev's theorem isn't limited to its practical application. It's also a testament to the power of mathematics and statistical theory. It reminds us that even in the face of chaos and unpredictability, there are still rules and patterns to be found. It's a testament to the power of logic and reason in a world that often seems anything but. In short, Chebyshev's theorem is more than just a theorem. It's a tool, a guide, and a beacon of hope in the sometimes murky waters of data analysis. It's our way of making sense of the nonsensical, of finding order in the chaos. So, Chebyshev's theorem is not just a mathematical concept, but a powerful tool for us data analysts. We have come a long way today, alchemists, from understanding what Chebyshev's theorem is to realizing its importance. Let's take a moment to reflect on our journey so far. Today, we dove into the fascinating world of non-normal data distribution. We discovered how conventional methods like calculating normal form, standard deviation, and z-scores might not always be effective. And that's where our hero of the day, Chebyshev's theorem, comes into play. We learned how this theorem, a gem in the crown of data analysis, provides a safety net when dealing with data that doesn't fit the mold of normal distribution. We saw how it doesn't make assumptions about the nature of our dataset, making it a versatile tool in our analytical arsenal. We then explored the intricacies of Chebyshev's theorem, breaking it down to its core components. This theorem, as we all now know, states that no matter the data's distribution, a certain percentage of values will always fall within a certain number of standard deviations from the mean. It's a powerful statement, isn't it? And we didn't stop at theory. We delved into the practical application of Chebyshev's theorem in the world of data analysis. We took a real-world example from the card payment domain where we analyzed merchant transactions. It was fascinating to see how this theorem helped us identify patterns and outliers in the data, assisting us in making informed decisions. But remember, alchemists, learning a new theorem is just the beginning. The real magic happens when you apply it, when you experiment with it, and when you start seeing the world through the lens of that theorem. So what are you waiting for? Grab your data sets, roll up your sleeves, and begin your journey of transforming data into invaluable insights using Chebyshev's theorem. Remember, as analyst alchemists, our job is to turn data into gold. So keep practicing, keep analyzing, and keep alchemizing. Don't forget to like, subscribe, and share this video. Until next time, happy alchemizing.